Let's continue with the back page of the PVA 2.2b linear motion worksheet. This is a back page number 7. The position function of a particle is moving on the coordinate on the coordinate line, and is given by x of t is equal to 2t cubed minus 21t squared plus 60t plus 3, x in feet, t is in seconds. Part A is asking, when is the particle at rest? Well, particle is at rest when the velocity is equal to 0. So we first need to find our velocity function, and from there we can set that equal to 0 and then solve for t. So to get from position to velocity function, we're going to find the derivative. So go through power rule for each of the terms. 2t cubed becomes 6t squared, 21t squared, 42t. 60t goes to 60, 3 is a constant, so 3 will go to 0. If we factor out the 6, we're going to get 6 parentheses t squared minus 7t plus 10. When is the particle at rest? We now can take this factored form, can factor a little bit more to get 6t minus 5, t minus 2. This is our factored form for our velocity function. Set that equal to 0. Solve for t, we get 2 in 5 seconds. Okay, part B, this will lead to part B here. When does the particle change direction or reverse direction? Well, part A will help because when the particle is at rest, that's a candidate position or a candidate t value for when the particle may change directions. So what we're going to do is we're going to put these on the sign line, put these critical points, put these time values on the sign line, and we're going to test values in each of these intervals. So here I can test 1 into the velocity function. So if I plug 1 into the velocity function, I get 6 times 1 minus 5. That's a negative value. 1 minus 2, that's also negative. So negative times negative is positive. Here, if I choose 3 as a critical value, a value between in this interval, if I plug 3 in for t, I get 3 minus 5, which is negative value. 3 minus 2, which is positive, so negative times positive is negative. Finally, I choose a value to the right of 5, so if I choose 6, 6 minus 5 is positive. 6 minus 2 is also positive. Positive times positive is positive. Technically, I should be multiplying by this 6 as well, but the 6 is already positive, so it's not going to change any of these. It's not going to affect the sign. If we can just have to focus on what's inside the parentheses. Okay, so that gives us positive. So at 2, there's a change in sign. At 5, there's also a change in sign. So we know that a particle reverses directions at t equals 2 in 5 seconds. Part C, what is the velocity when acceleration is 0? Okay, so first, we need to find out when the acceleration is 0. If we can find out the moment in time when the acceleration is 0, then we can take that t value and evaluate the velocity at that moment in time. So first step, let's find acceleration. So to find acceleration, we take our velocity function and we find the derivative, go one derivative down, so 6t squared becomes 12t, 42t becomes negative 42, 60 goes to 0. So when is the acceleration 0? We're going to set our acceleration function equal to 0. So 0 is equal to, if I factor the 12t minus 42, I get 6 parentheses 2t minus 7. Solve for t, I get t is equal to 7 halves. So 7 halves is the moment in time when the acceleration is 0. Okay, so this is the time that we want to figure out. This is the moment in time that we want to figure out, that we want to plug in to figure out what the velocity is. So if I plug 7 halves into the velocity function, so 7 halves goes into this function. I didn't show the work here, but if we were to plug this in into the velocity function, we're going to get negative 13.5 feet per second as our answer. Hey, what's the speed when the acceleration is 6 feet per second squared? So let's first find out when the acceleration is 6 feet per second squared. So we can set our acceleration function equal to the acceleration value that we're looking for. In this case is 6. Right, solve for t, divide both sides by 6. Solve for t, add 7, then divide by 2, and we get t is equal to 4. So we know that the acceleration is 6 feet per second squared at t is equal to 4. Okay, speed is related to velocity, so if I plug 4 into the velocity function. Here's the velocity function again. It didn't show the work, but just plug 4 in for all the t values for velocity, and the result will be negative 12. Now, negative 12 is the velocity at 4 seconds, but we're looking for the speed. So speed will always be the absolute value of the velocity. It will always be the absolute value of the velocity. So if the velocity is negative, if we want to find the speed, it's always the absolute value. So in this case, speed is 12 feet per second. Okay, part E, what's the displacement from t equals 1 to t equals 3? Displacement is simply the change in distance between two time periods. So if we can find out what the position at t equals 3 and the position at t equals 1, we can simply subtract x of 3 minus x of 1. So if I plug 1 into the position function, here's our position function that's given to us, we get position of 44. If we plug 3 into the position function, we get position of 48. So displacement is simply end position minus the initial position. So 48 minus 44 will simply be 4 feet. All right, what's the total distance? Now total distance, we have to now factor in the possibility that this object may be backtracking. So if this object is backtracking, meaning that if it changes direction, we have to make sure that we count its distance going backwards as positive value. So the way we do that is we're going to find the position at the endpoints, in this case 1 and 3. So position at 1 is 44, position at 3 is 48. Now we also include 2, and the reason why we include 2 is because there's a change in direction at 2. So if you can imagine what's happening here, this particle is moving forward or moving to the right from 1 second to 2, and then it's going to stop and it's going to start moving backwards. So when it moves backwards, we have to make sure we mark that point, because we have to be able to count any backward motion that it travels as a positive distance. So that's why we include 2. So if we find out the distance between 1 and 2, and then find the distance between 2 and 3, then we can take each portion, make both portions positive, and then add them together to find out the total distance traveled. So position at 1 is 44, position at 2 is 55. From here on, from this point forward, this object is going to move to the left. So that's why at 3 he's going to go backwards to position 48. So now if we find the positive distance between each of these intervals, and we can add them together and find the total distance. So between time t equals 1 and t equals 2, this particle is going to travel a distance of 11 units, and then, or 11 feet. And then from 2 to 3, he's going to move backwards. 55 minus 48, he's going to travel 7 feet. So then 11 plus 7 is 18. Now notice that this object only makes forward progress, displacement of 4 feet. However, its total distance that it travels in that time interval is 18 feet. So he's basically moving forward 11 units and backwards backwards 7 units, giving us a net gain of 4 units, but total distance is 18 feet. All right, number 8. Velocity function is given. All right, when is the particle at rest? We can set the velocity equal to 0. So this is nicely factored already. We can set each parentheses equal to 0, 1, 3, and 5 seconds. When its particle moves to the left, well, we're going to make a sign line and then test each of the intervals. So here I can choose 0. Here I can choose 2. I can choose 4. I can choose 6. So I'm going to take each of these test points, plug into the velocity function, and determine the sign. Okay. So if I plug 0 into the velocity function, I'm going to get a positive value. If I plug 2 into the velocity function, I'm going to get negative. 4, I'll get negative. 6, I'll get positive. And so here we can see that the negative portions is between 1 and 3 and between 3 and 5. So that's part B. That's when this particle is moving to the left. When does a particle change direction? Change direction would be where the sign changes. So sign changes only at 1 and 5. Notice that there's no change in signs at 3. So t is equal to 1 and 5 seconds. All right, number 9, the ball is thrown vertically upwards from the edge at the top of the building, 160 feet tall, with an initial velocity of 24 feet per second. Height is given by the function, so h of t. So the height of the ball at any moment in time is negative 16t squared plus bt plus c. Find the values of b and c. Okay, now c is simply the initial position, and b is the initial velocity. So that's just simply the formula that we're going to be working with here. So the b is the initial velocity, and the c is the initial position. So initial velocity is 24 feet per second, and the initial height is 160 feet. So we can replace b and c with the values that we're going to be using. So the position at any moment in time, using the given position and velocity, is negative 16t squared plus 24t plus 160. Okay, so how long does it take for the ball to reach its maximum height? Now let's think about the ball movement here. It's thrown vertically upward, so it's going to go up, and then it's going to eventually come back down. When it reaches its maximum height, that's also the point in time when the ball is not moving. It's basically at rest for that moment in time. So when that ball is at rest, that is also where the velocity is 0. So if we set the velocity equal to 0, we can identify the time when this ball has reached its maximum height. So we find the velocity function by going through power rule, find the derivative of our position function h of t. So we go through power rule, negative 16t squared gives us negative 32t. 24t becomes 24, 160 goes to 0. So now we have our velocity function. If we set velocity equal to 0, that will identify the time when its maximum height has been reached. So we set the velocity equal to 0, solve for t, so subtract 24, divide by negative 32, and we get 3/4 seconds. So this is the moment in time when the ball has reached its maximum height, because this is also the moment in time when the velocity is 0. So if we take 3/4 and plug into the position function, then we can identify the height at that particular moment in time. So if I plug 3/4 in for t, I didn't show the work here, but the calculator will allow you to get to this numeric value, 169 feet. How long before the ball passes the top of the building on the way down? Okay, so how long before the ball passes top of the building on the way down? We can set the position function equal to the height. So we want to figure out the moment in time when when the ball has reached the top of the building. Okay, we can set that equal to 160, and then if I subtract 160 from both sides, and then it'll be equal to 0, factor out the negative 16, and I'm going to get t is equal to before I can solve for t. So t is equal to 3/2 seconds. All right, part E. Now, how long does it take for the ball to hit the ground? The ball is going to hit the ground when h of t represents the position that we're looking for, when position is 0. So when the height of the ball is 0, we can set that and solve for t. Here, this is already the factored form. So the factored form for h of t, I worked it out up here. I factored out the negative 16, the negative 8, and then I continue factoring the 2t squared minus 3t minus 20. So I take that factored form and I set that equal to 0. When I set that equal to 0, I'm trying to identify the time when the position is 0, or the height of the ball is 0. So then I set 2t plus 5 equal to 0 and t minus 4 equal to 0. 2t plus 5 equals 0. I'm going to get negative 5/2. So for this problem, we're only looking at where t is greater than 0. So we're only going to take the positive time value. All right, the speed of the ball. So the speed of the ball when it hits the ground, we know it's going to take 4 seconds for it to hit the ground. So if I plug 4 into the velocity function, because speed is very much related to the velocity, so I'm going to go through the velocity first, and then we can determine the speed. If I plug 4 into the velocity function, so velocity function is negative 32t plus 24, plug 4 in for the t value, I get negative 104. Negative 104 is the velocity of the ball, but we're looking for the speed, so speed is always the absolute value of the velocity. So in this case, the speed is 104 feet per second. Right? What's the speed of the ball at 1 second? So again, we're going to use velocity to get to the speed. So plug 1 into the velocity. V of 1 is equal to negative 8. So again, you plug 1 into the velocity function here. Negative 8, but negative 8 is the velocity. So to make that adjustment, we make this, we take the absolute value of the negative 8, and we get positive 8 feet per second.